Question number 36. The first element of each group differ in many respects from other members of their respective group. This anomalous behavior is generally attributed to their small size and large charge density. Consider the following properties associated with lithium: the decomposition of its carbonate due to heating of its nitrate to form its oxide with liberation of NO2 and O2 gases, formation of hydrate by its chloride, and its hydrogen carbonate does not exist as a solid. So, the examiner is interested to know that which of the above mentioned properties are anomalous to other alkali metals. So students, if we talk about the other alkali metals, if we talk about the carbonates, so the metal carbonates are stable to heat. They do not decompose upon heating, whereas lithium carbonate does. It forms the oxide plus CO2 gas is liberated. So this is anomalous behavior. Let us look at the second option. Heating of its nitrate to form its oxide with the liberation of NO2 and O2 gases. So students, the alkali metal nitrates, upon heating, they form the nitrite plus O2 gas is liberated. Whereas it is given to us that the heating of lithium nitrate forms the oxide plus NO2 and O2 gases are produced. So this is also anomalous. We can look at the option third now. So formation of hydrate by its chloride. We know that lithium chloride forms a hydrate, whereas the other alkali metals do not form hydrates. So this is because of the high charge density on lithium ion. So this is also correct. Let us look at the fourth option now. Its hydrogen carbonate does not exist as a solid. This statement is also correct. The other alkali metal bicarbonates are fairly stable and they exist as solids except the lithium hydrogen carbonate. Okay. So we can see that all four of these statements are correct. So we have to mark option 4 as the correct answer to our question. Let us look at the next question now. Question number 37. Consider the following statements regarding the reaction of group 16 elements with halogens and select the incorrect statement. So looking at the first option, among the hexahalides, hexafluorides are the only stable halides. So this statement is correct. Only the hexafluorides are stable because of steric reasons. Let us look at the second option now. The tetrafluorides are sp3d hybridized and have a seesaw geometry. This statement is also correct. If we talk about any tetrafluoride, EF4, so there will be a lone pair of electrons on E. So the hybridization will be sp3d and it is going to have a seesaw geometry. Okay, so this statement is also correct. We can look at the third option now. Compounds of oxygen with chlorine are named as oxides. Yes, this statement is correct. So we know that oxygen is more electronegative than chlorine, and in the compounds, oxygen is going to have a state of -2. So it will be named as an oxide rather than a chloride. So statement 3 is also correct. Let us look at statement 4 now. The monohalides of selenium are dimeric and they disproportionate to Se6 and Se0. Students, we know that the monohalides are dimeric. So Se2Cl2. When it disproportionates, it forms SeCl4 plus Se. So it goes to a state of +4 and a state of 0. So the fourth statement is incorrect because it is given to us in the option that Se plus 6 is formed, which is incorrect. So students, we have to mark option 4 as the correct answer to our question. Let us look at the next question. Question number 38. Consider the given statements in general and mark the correct statements out of the following. Let us look at the first statement, S1. The contraction in transition series is attributed to the imperfect shielding of one electron by another in the same subshell. So students, this statement is correct because we know that the shielding of D and F electrons are very, very poor, and so there is a contraction in the size of the transition series elements. So statement 1 is correct. Let us look at statement 2. The shielding of one F electron by another is less than that of one D electron by another with the increase in nuclear charge along the series in the same subshell. This statement is also correct, students. We know that the shielding ability of S is the greatest, followed by P, followed by D, and then followed by F. So the D and F orbitals are very poor shielders, but if we compare between D and F, the shielding in F will be further poorer than that in D. So students, S2 is also correct. Let us look at statement 3 now. As a result of lanthanoid contraction, zirconium and hafnium have almost identical radii, which accounts for their occurrence together in nature and for the difficulty faced in their separation. Students, this statement is also correct. Zirconium and hafnium have almost similar size and they occur together in nature. So, if we look at the options, the correct option is option 4. Let us look at question number 39 now. Experiments were performed on 4 different colloidal solutions A, B, C and D, and the following observations were noted. So first experiment was electrophoresis. In Sol A, dispersed phase moved towards the cathode, and in Sol B, the dispersed phase moved towards the anode. So we can see that the Sol A, since the Sol particles move towards the cathode, it means that the Sol particles must be positively charged. While in Sol B, we can see that the dispersed phase moved towards the anode, which means that the Sol particles must be negatively charged. Let us look at the second experiment now. So during electroosmosis, the dispersion medium of Sol C moved towards the cathode, whereas the dispersion medium of Sol D moves towards the anode. So students, we know that during electroosmosis, the movement of colloidal particles are prevented by some suitable means, and when potential is applied, it is the dispersion medium which starts to move towards the oppositely charged electrode. So in the Sol C, we can see that the dispersion medium moves towards the cathode. It means that the dispersion medium in Sol C must be positively charged. So the Sol particles present in C must be negatively charged. Whereas if we talk about Sol D, it is given that the dispersion medium moves towards the anode. So it must mean that the dispersion medium is negatively charged. So the Sol particle will have to be positively charged. Let us look at the options now. Sol A and Sol C are both positively charged. Sol A is positively charged, whereas Sol C is negatively charged. So option 1 is incorrect. Let us look at option 2 now. Mixing of solutions A and D lead to coagulation. So students, Sol A and Sol D are both positively charged and their mixing may not lead to coagulation. So second statement is also incorrect. Let us look at statement 3 now. For coagulation of Sol D, K4FeCN6 has a greater coagulating ability than K2SO4. So since Sol D is positively charged, it means that the anion used for coagulation should have a greater anionic charge. So in K4FeCN6, the charge on the anion is 4 negative, whereas in K2SO4, the charge on the anion is 2 negative. So we can see that K4FeCN6 will have a greater coagulating ability. So statement 3 is correct. Let us look at the fourth option now. Mixing of solution B and solution C will cause coagulation. We can see that Sol B and Sol C are both negatively charged and their mixing will not lead to coagulation. So students, the answer which we have to mark for question number 39 is option 3. Let us look at the next question. Question number 40. Consider the 4 coordinated complexes of Pt plus 2 with ligand Bn, which is butane 2,3-diamine, which are given below. So we have been given 2 structures, and in this question the examiner is interested in knowing about the optical activity of these structures 1 and structure 2. So students, if we look very carefully at the structure, so in the first structure we can see that the structure has a plane of symmetry. So the structure on the right hand side of the mirror is an image of the structure present on the left hand side of the mirror. So this has a plane of symmetry, so it is optically inactive. And now if we look at the second structure does not have any plane of symmetry or any center of symmetry. So students, the structure given in option 2 is optically active. So it is a very simple question. We just need to check for the center of symmetry or the plane of symmetry in the given structures. So looking at the options, the correct statement is given in statement number 2. So we have to mark option 2 as the correct answer to our question.